Bismillahirrahmanirrahim. Alhamdulillahi wassalatu wassalamu ala rasulillahi wa ala alihi wa ashabihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin ya rabbal alamin. Assalamu alaikum. This is Muhammad Sanor, and in this session I will discuss about teaching learning based optimization, which is TLBO. So teaching learning based optimization is a population based optimization algorithm that simulates the teaching and learning process in a classroom setting. It was introduced by Rao et al. In 2011 and has since been applied to a variety of optimization problems. So TLBO is a population of solutions represented as vector of decision variables to search for the optimal solution. The algorithm proceeds through a series of iterations, with each iteration consists of two phases, which is the teaching phase and the learning phase. It based on the efforts of influence of a teacher on the output of learner in a class. The teacher and learner are the two major components of this algorithm. So the working of TLBO is divided into two parts, which is the teacher phase and the learner phase. So in the teacher phase, simulates the learning of the students, which is learner, through a teacher, and during this phase the teacher conveys knowledge among the learner and put efforts to increase the mean result of this class. On the other hand, in the learner phase, simulates the learning of the students through interaction among themselves. The student can also gain knowledge by discussing or interacting with the other students. The learner will learn new information if the other learner has more knowledge than him or her. So this is the flowchart of this algorithm. So initialize number of students or populations, calculate the mean of the decision is decision variable, and identify the best solution with the best teacher, and modify the solution based on this equation. And if the new solution better than the existing, and if the condition is true, then accept, and if the condition is false, and then the reject, and go for the learner phase. Select any two solutions randomly defined by xi and xj. If xi better than xj, and if the condition is true, then select or use this equation. If the condition is false, then use this equation. So if new solution better than the existing and the condition is true, then go accept the solution. If the condition is not true, then reject the solution. And if new solution better than the existing, and this is the final value of the solution. So in the teacher phase, generate a new solution using best solutions so far mean of the population by this equation. Actually, where is the x new, the new solution, and x is defined for current solution, and r is the random number between 0 and 1, and x best is defined for teacher, and tf is the teaching factor, either 1 or 2, and x mean of the main solution, and tf is equal to the round 1 plus random number. And then calculate the new fitness and apply the greedy selection. Accept the new solution if it is, then it is better. If it is not better, then keep it as previous. So after complete the teacher phase, we'll go for the learner phase. So in the learner phase, new solution is generated with the help of the partner solution, but define the partner by xp, and if the problem is maximization, then use this equation, and if the problem is the minimization problem, then use this equation, and then perform the greedy selection. This is for a maximization problem, and this is for the minimization problem, and then update the solution if the condition is true, otherwise not. So if I summarize this discussion, so set the population size and maximize the number of iteration, then find a teacher, which is best teacher, and find the mean of the subject, and then generate a new solution by this equation, x plus R into x best minus TF x min, and then calculate the new fitness and apply the greedy selection. Then select the partner and interact with the partner, find the new solution, and calculate the new fitness and apply the greedy selection and memorize the best solution. Go for the next iteration, and this loop will be continued until the iteration is complete. So now I will discuss elaborately with a numerical example. This is a maximization problem. F of x equal x1 square minus x1 x2 plus x2 square plus 2x1 plus 4x2 plus 3, and the domain is minus 5 is less equal x1 x2 is less equal 5. So the teaching learning based optimization parameter setting used only for illustration. So this value will be randomly chosen. Say for the population size is 5 and number of iteration 20, and the dimension of this problem will be 2 because there is the two variable x1 and x2, so the dimension is 2. So our goal is to calculate and update these variable actually. So now we find the random value for the 5 population size is 5. By using this equation we get this value by this equation, and we calculate the function value from the maximization problem from this equation. Now we put the value in this column. So now we have to select the best teacher. So we select this is the best teacher because this is the maximization problem. So in this row, in this column, so 48.6753 is the maximum value. So we select this is as x best, and now calculate the mean value from x1 and x2. So this is the x mean. Now we put this value in this equation by for calculating x1 and x2. So x1, x2. So we get x best is equal to 4.1338, 4.5751. So this is the iteration 1 in the teacher phase. And for the first student, we select for the now we calculate the for the first student. So this is the x best for best teacher. Now we select the for random value for R, say for example 0.7 and 0.4, and TF equal to 2. This is also a random value. TF is equal to 2. Current the value of TF will be 1 or 2. Say for TF is equal to 2. Now we obtain the value of x1 and x2 by putting this value in this equation. So x1 we get 3.5398 and x2 we get minus 2.7471. So this value will remain in our domain, minus 5 to 5. Now our this x new. Now we go for the greedy selection. So f of x new is equal to 28.8918. So we look this value is less than the function value. So there will be no update. Because this value is less than 31.9648. So this value keep as previous. So there will be no update. See, there will be no update. So now we go for the learner phase. So learner phase new solution is generated with the help of the partner, say for XP by the so this is the maximization problem. So we select this equation and perform the greedy selection by this equation. Now select the partner. Say for example we select the third student as a partner, which is defined let XP. So this is the partner, and we select the value, random value 0.3, say for example 0.3 or 0.6. So we see here the F1 is 31.9645, and our FP or the partner function value 13.2971. So this is less than of F. I mean, if fp is less than f1 or f. So we select this equation, actually this equation. So now we calculate the x1 and x2. We obtain x1 is equal to 5. We get actually 5.2105, but this is not in our domain. So we get x1 is equal to 5 and x2 is equal to minus 5. So we get x new 5 minus 5. 5 minus 5. Now we go for the greedy selection. Greedy selection, f of x new is equal to 68 and f of x1 is equal to 31.9645. So since here we see 68 is greater than 31, so there will be update. I mean x1 with x new. Now put this value by replacing this value. So we get our new value 5 minus 5 and function value 68. So for the second student we get from this value x best is 5 minus 5, because this is the maximum value. So we select as this as best. So this is our equation. Now we select random value for r, say for example 0.5 and 0.6, and tf is equal to 1. So we obtain x1 and x2 by putting this value in this equation. So we get x new 5 minus 5. Now we go for the greedy selection. F equal to x new is equal to 68 and f of x is equal to 32.6168. So we see the x new is greater than our f, so there will be update. So we replace this value by this new value. So we put this value in this row. See, in this row. Now for the second student, in the learner phase, select the partner. Say for example, you select as a partner in the fifth student, select as a partner. So this and select a random value 0.5, 0.4 and 0.3, and we see f equal to here f equal to 68 and f equal to 68 and fp partner value is 41.4537. So we see here f is greater equal fp. So we select this equation, and now we get the value of x1 and x2 by putting this value in this equation. So here our new value x1 and x2 is equal to 5 minus 5. Now we go for the greedy selection. This is the greedy selection. So f of x new is equal to 68 and f of x is equal to 68. So these value are same. So you can replace this value or can remain same, because this value all are same. Now for the third student, select the best teacher from this value. We select this as a best teacher for 5 minus 5. Now select the random value for r, say for example 0.1 and 0.4, and select the value tf, say for 2, and we calculate the x mean from these values. So this is the x mean. Now putting these values in this equation, we get x1 and x2 minus 3.6992 and we get x2 minus 1.4828. So this is our x new. Now perform for the greedy selection. F of x new is equal to 0.0715 and f of x 13.2971. So we see here f of x new is less than f of x, so there will be no update. So keep the value as in previous. So there will be no update. The value will be same. Same. So now for in the learner phase, select as a partner. Say for example, we select the fourth student as a partner, and now select the random value for r. Say for example 0.6 or 0.2, and we see here is the value of f is 13.2971, and the partner value is because we take the partner as a 4. for number, so there is 48.6753. so we see here is f is less than ap, f is less than ap, so we select this equation. Now put this value in this equation, we get x1 and x2 0.9882 and x2 is 1.2901. so we get x new. This is, now we go for the greedy selection, f of x new and f of x auto. So we see f of x new is less than f of x, so there will be no update, the value will remain same as in the previous. So see, there is in the previous value same. So now for the fourth student, select the best teacher from this value. Select this value as a best teacher and select the random value for r, say for example 0.8 and 0.4, and the value of tf is equal to 2. Now put an x mean we get from this value, the average value x mean. Now put these values in this equation, we get x1 and x2. So this is our x new, x1 and x2 value. Now we will go for the greedy selection. F of x new we get 36.8425 and f of x 48.6753. so we see here is the f of x new is less equal f of x, so there will be no update, so the value will be same as previous. So now go for the learner phase. Select, we have to select the learner partner. So we select the third value as a partner. This is the third value as a partner, and here is the f equal 48.6753 48.53 for fourth student, and we select the partner value is 13.2971. so we see here f is greater than ap, so we select this equation. Now put this value in this equation, we get x1 and x2 5 and 5. so our x new equal to is 5 and 5. Now go for the greedy selection. F of x new is equal to 58 and f of x equal to 48.6753. So there will be update. So we replace the value of 4 student by this value. See this value. So now for the fifth student in the teacher phase. So we select the x best from this value, x best. So and so we select the random value for r 0.7 and 0.5, say 0.705, and put the value and we get the tf, say for example 1. Now put these values in this equation, we get x1 and x2. Our x new equal to x, and now go for the greedy selection. F of x new is equal to 25.0629 and f of x 41.4537. so there will be no update because f of x new is less than the f of x. Now we go for the learner phase. So we have to select a learner. We select the second student as our partner. So this is the partner. So and we select the value, random value for r, say for example 0.7 and 0.7. so f equal to, here we see f for 50 student 41.4537. here is the f, and the partner value, because we select the 2 number student as a partner, so there is 68. So f is less than ap, then we select this equation. Now put this value in this equation and we get the value x1 and x2 3.8971 and minus 2.1053. so we get x new. Now go for the greedy selection, f of x new and f of x we get. So we see f of x new is less than f of x, so there will be no update. So at the end of this iteration, new solution obtained is this. this. So at the end of the first iteration, I will get this solution, and at the end of the fifth iteration I will get this solution, and after the 15th iteration I will get this solution, and after 20th iteration we will get this solution. So if you want to perform more than you can perform more, then you can set more number of iteration, then you will get more better and better solution. So this is the sample working of TLBO algorithm. So now we can prove this problem in Python code by using Python code. This is the Python code actually. So this code is defined as objective function. This is for objective function, and this codes for the TLBO algorithm, and this for the iteration. This codes for the iteration. So in the learner phase, this is the learner phase, and after return the best solution found. This is the code for the best solution, and this is the code actually. After putting this codes, and we can simulate our problems by this code, and after simulates the run the program, we get this value. This is the best solution, 5.5 and -5, and the best fit is 68, which is already discussed theoretically in the previous. See, there is the best solution 68, 5 -5, 5 -5. So that's all about my topics for the time being. Thank you so much.